Okay, so you looked over some notes on how to solve some systems. Here are a couple others that increase the difficulty a little bit. Try one right now. Okay, we should have gotten n is greater than 8 or n is less than -10 with our arrows pointing in different directions. Let's go ahead and move on to number 2. Be careful of this one. We have variables on both sides of the inequalities. Okay, and for the second one is an and problem. So 0 is less than n, which is less than 10. If you left it as just the n is less than 10 and 0 is less than n, that's fine too. And so notice how I split them up into 2 separate inequalities. Makes it a whole lot easier to solve. We end up with this little dumbbell with open circles for number 2. So this is special cases notes. So let's start getting to some special cases. Okay, this first one's going to be a very obvious special case, and this only applies for or. So 3 and 4 are only for or, 5 and 6 are only for and. So let's talk about the or special cases first. For number 3, well, we're going to solve it just like we would solve any compound inequality. This one, we subtract 3, so we get x is greater than or equal to 10. Sorry, -10. Or x is less than or equal to -6. Okay, so if we do a quick look at some overlapping inequalities, greater than or equal to -10, less than or equal to -6. Well, one inequality starts low and goes to the right. The other inequality starts right, high and goes to the left. And so in this case, because it's or, so long as it satisfies at least one of these inequalities, it's good. So every single number on the number line is going to satisfy this inequality. So our answer is going to be all real numbers. Okay, and so we want to graph the entire number line, get all real numbers. Okay, remember for or we want to graph anything that our graphs have. Okay, and so in this case, every single number satisfies at least one of these conditions. If we plug in any number for x in the first inequality, that doesn't work, it will work for the second inequality. So any number for x will work for one of these inequalities. Okay. Let's take a look at number 4. Again, simple inequality to solve. We have n is less than 5, or n is less than or equal to -10. Okay. Again, let's do a quick practice. So we have 5, 0, -10. Okay, so n is less than 5. Open circle at 5, going left. N is less than or equal to -10. Closed circle, going left. Okay. In this case, anything that's 5 or greater is not going to satisfy any of these. So we know everything to the right of 5 is no good. But this space in between, which one is it? For or problems, is whichever one encompasses more. Okay, so it's kind of this back one. For or problems, we're trying to graph as much as possible. And so if there's a value for n or x, whatever the variable may be, that satisfies even one of these conditions, then that's the one we want to choose. Okay, so it's just going to be n is less than 5. And that's this inequality right here. Okay, n is less than 5. We're trying to graph as much as we can. Okay, so those are some or special cases. Let's take a look at some and special cases. Okay, So for these two problems, we have 56 is less than negative 8x, and negative 8x is less than 48. I split them up because it makes it clear to me. If we divide by negative 8, we get negative 7 is greater than x, and x is greater than negative 6. Okay, so let's put in our practice number line. Making it better. It's definitely making it better, I can tell. Okay, so we have negative 6, negative 7, negative 8, negative 5, negative 4. This one on the left, less than negative 7. So at open circle at 7, pointing left. Okay. Greater than negative 6, open circle at 6, pointing right. Okay. So this is where it gets really weird. We've seen problems like this, but they were always or. Okay. For and, our value has to satisfy both conditions. Both this negative 7 is greater than x, and x is greater than negative 6. There is no value for x that satisfies both of these inequalities. Okay. And is a both thing. Okay. And so because there is no value for x, we can pick any value that might satisfy one, but won't satisfy the other, or might not satisfy either, because there's no value for x that satisfies both, and it has to be both for and problems. This is going to have no solution. No solution. Remember, and must be both. And so if we keep that in mind for the second one, we have a is less than 8, and a is less than or equal to 1. Okay. Something like this. We'll set up our practice. 0, 1, 8. So a is less than 8. So open circle at 8, going left. Closed circle at 1, going left. Okay. Like I said, we are looking for values of a that satisfy both of these inequalities. If we pick 4, yes, 4 is less than 8, but is not less than or equal to 1. Okay. And is a both kind of inequality. And so for this example, we're just looking at the overlap. So from everything from here into the left. All of this stuff is good, but it's not good enough. It has to satisfy both of these inequalities. And so really our solution is just a is less than or equal to 1. Okay. If nothing else, just remember, or could be either, but and must be both. Okay. Or could be either, but and must be both.